Hey everyone. I just wanted to do an update on my progress on Toy Engine, and it's been about a week since my last dev vlog, so wanted to show you the progress that I've made. So in the last dev vlog, I talked about creating uniform buffer objects, which allowed me to upload lighting data to the shader to OpenGL and to access them across multiple shaders by using uniform buffer objects. So I used that mostly to send, I used it, so far it's being used to send lighting data to the shader. So you can see here in my render.cpp all the light uniform get uploaded using uniform buffer objects. So this week I worked mostly on I was kind of learning new concepts and going over the advanced uh, was advanced let's see, what was that section called? It was advanced OpenGL and learn OpenGL. Yeah, so advanced OpenGL on learnopengl.com. I learned about depth testing, stencil testing, blending, face calling, and a bunch of more advanced rendering topics. So one of those topics in there that you can see was where is it? Cube maps and environment maps, which basically allow you to set a background to your scene. Since I thought that would be a good thing to work on, since it would definitely helps with the um, kind of the visual fidelity of the project. So here you can see I got a big kind of like mountain lake background in the image. So you can see if I go into orthographic view that actually it's just um, a cube that kind of sits behind the models. But if we remove like translation, then it just always appears, and we sample using a direction vector, then it just kind of always appears like it's behind everything. So yeah, that was cube mapping was an interesting topic. So you can see I have it in here. And yeah, no matter how much I translate, the background always stays in place, which kind of gives that parallaxing effect. Additionally, I've been in that QMap section, we learn about environment maps, which allow you to do kind of fake reflections and refractions. So I've updated my shading model to include environment QMap based reflections and refractions. So here you can see that if I turn up the metallicness of the parameter in my shader model, that all the models, the surfaces reflect the environment map, and you can see they act as reflections when I kind of rotate the models around. So, uh, but yeah, let me show that off a little more. So yeah, as the models move and rotate, the reflections change, and it's all based off of sampling the cube map. So you can see here that the models don't actually appear in each other's reflections as you would expect. I've also added kind of approximation of soft reflections. So here you can see these models have kind of perfect mirror reflections. But as I turn up this roughness parameter, as it goes up and up, oh yeah, here you can see it. The reflections become a lot softer and less well-defined. So yeah, you can see, yeah. And I've done this by using mip-maps actually. So I created a bunch of different levels of fidelity of sizes. Uh, I've sampled the Q map at a bunch of different texture resolutions. And then as the roughness increases, I sample a lower and lower resolution texture map or mip map. So that as it goes along, you get less and less detail in the reflections. So it's kind of banded where like at each like um step, you sample a slightly smaller and less detailed map of the cube map texture, and that's how I'm getting this soft reflections effect. So along with reflections, we can also do refractions and kind of transmission effects. So here we have it kind of looking like a glass object. I set it to 1. Oh, that's 10. So I've set it to 1, then it appears like it's kind of like translucent, like the models appear like translucent like air. And as it goes up, the refraction becomes stronger and stronger till eventually you get total internal reflections, and it just appears like a reflective surface. So somewhere around, 2.42 is about, the refraction index of diamonds. So you kind of get this very nice glass looking effect here. You can also kind of combine reflections and refractions, but you really shouldn't do that. There's no material that actually has that property. And just like reflections, you can have kind of soft refractions, create like a cloudy effect by turning up the roughness. So the roughness affects reflections and refractions. And it does that by sampling lower resolution versions of the texture cube. So yeah, that's where I'm currently at. Let me show you some of the implementation details over here. So here you can see I've created a new class, a new object called shader box. Um, so this is basically has vertex data for the box, and then I create the box, I assign it, and then I assign a cube map texture to it. Cube map textures are very similar to texture 2D. Um, kind of one of the differences is I can generate maps, but yeah, but that's pretty much it. The OpenGL implementation is very similar to Texture 2D. So I kind of did the same thing where I created an abstract texture cube class, and then I created a OpenGL implementation. And over here, you can see that implementation. A lot of the details of how you implement cube map textures is very similar to implementing textures 2D, except you just use GL texture cube map and um, you bind your texture to this OpenGL texture cube map instead of texture 2D as you would for a 2D flat texture. So that's what I did this past week. Looking forward, I really want to work on implementing a frame buffer so I can do post-processing effects. I think that will be uh, have a good impact on the project. And I want to work on additionally implementing an orbit camera. As you can see, using the fly camera to demonstrate these scenes has kind of been a pain. It's not that easy to work with. So I want to implement a kind of orbit camera like you see in Blender or other 3D applications. Beyond that, let's see. What else can we work on this week? I mean, there's a ton. Um, oh, there was another thing I really wanted to do, but it's escaping my mind. Oh, I also implemented backface culling. That was pretty simple. I can show you over here. In the render API, it basically involved creating two new render call functions called call face, where you set which side of the face you want to call, and the winding order. So whether, counterclockwise defines the front of the face or clockwise defines it. And currently, right now, when I begin a render scene, I enable face calling. Um, and the only time I disable that is when um, rendering the cube map. Here, if I can show you over here, or maybe it's in the skybox. So yeah, when I render the skybox, you can see I save the current call face state, then I set it to, then I disable it, and then I set it back to the previous state at the end of rendering the skybox. So yeah, I also implemented backface culling which has a huge performance benefit. So, as they say, as the author of Learn OpenGL says, it's at least 50% improvement, right? So, yeah, that's where I'm at. Next, I'm going to be working on frame buffer objects and implementing that. And then, oh, yeah, so now we'll kind of go into implementing post-processing effects. And then there were some other things I wanted to implement from this section. Oh, maybe blending for transparency would be really good. Oh, and I should do some anti-aliasing as well. All right, I'll do that as well. All right, that's all I have for this week. Thank you for listening.